All right, so here's one more trig equation that we're going to solve. The last one, we did a lot of algebra. This one, we're going to look just at something else that can complicate it. When I look at this, the first thing I noticed is I don't really like secant. Actually, we need to know what we're doing, right? So let's say we're solving, let's just say we're solving this, okay? So really what that means is I'm needing to find the values of b that would make this true. And so when I look at this, things that, it doesn't seem easy to me, things that make it seem complicated, A, the secant, and B, this over 3, I really just wish that wasn't there. And so what I'm going to do is I'm going to take care of one of those things at a time, because we don't take care of multiple things. This is secant of b over 3. And I know that secant is related to cosine. So what if instead I said this was cosine of b over 3? Well, I know secant and cosine are related because they're reciprocals. So this b over 3, that's the angle. That doesn't reciprocate. But the ratio for secant is 2. The secant ratio here is 2, which means the cosine ratio would be 1/2. Okay, so that looks way easier. But I still have that b over 3. I just wish that over 3 wasn't there. I mean, you know, if only this were something like cosine of theta equals 1/2. I mean, that's easy, right? And this is the thing, we can do that. Let's just cover this up temporarily. Let's just call that theta. So we'll say theta is b over 3. And what that means now is that we do have this equation. Then I can just solve that. I mean, that looks easy. So all I'm doing is I'm taking that b over 3 and I'm covering it up temporarily. I mean, I'm just making it look simpler for myself so I can handle one thing at a time, so I can find the angles and worry about the over 3 later. So when I look at this, I'm wondering, where is cosine equal to 1/2? And so if I think about my unit circle, I know, or my automatics, or I could look at my automatics table, I know cosine is 1/2 at pi over 3. And I know it's also equal to 1/2 at, nope, not there, because that'd be negative, you know. So positive in the 4th quadrant. So I could say 5 pi over 3. So this tells me that theta is equal to pi over 3, or theta is equal to 5 pi over 3. Now this is only if we only did one rotation, you know. I just said only twice. But, you know, I could go anywhere. I could do a coterminal angle after that, which means I could add 2 pi to this angle as many times as I wanted. So that's, n is representing a whole number of times, actually an integer, so n is an integer, you know, positive or negative whole number, because I could do any number of rotations from there. So this is good. I know what theta is, so I have it solved, right? Oh, if I look back, I was looking for b, not theta. So this is where theta, what was theta? Theta was b over 3, so I can just uncover this now. My theta was really b over 3, so b over 3 is equal to pi over 3 plus 2 pi n. And then, oh, well, I could solve that, couldn't I? I mean, if I want to get b by itself, I'm just going to multiply both sides by 3. Okay? And so that would leave me with b equals, well, that 3 gets distributed, so pi over 3 times 3 would be pi, and then 2 pi n times 3 would be 6 pi n. And similarly, we could do the same thing with this one here. And if we did that, we would get b equals 5 pi. I'm just repeating the process in my head. Plus 6 pi n. And again, remember n is an element of the integers. So that means that these are all of the angles that would fit our original equation. So if we plugged those in, they would work. So it's all about handling your difficulties. Notice I took care of secant, one step at a time, took care of my, I don't like that over 3, took care of that one step at a time, found my angles, then I came back and dealt with the 3. Hope this helps. Have a great night.